a linear function, what does that look like in terms of the parent function and the parts of it? So in other words, what is the equation of a linear function? And again, this should be found in your formula sheet somewhere, maybe. Yep. Okay, so linear equations, this is what you're used to seeing it. Y equals mx plus b. This is in point slope, and this is standard form. The most used one is going to be in slope intercept form. So I'm going to go write that down and talk about what it means. So you have y equals mx plus b. So let's talk about what the parts of this formula mean. So you need to know that this right here is the slope, and plus b is the y-intercept. Okay, I'm going to go ahead and write it down in standard form as well. So in standard form, what does that look like? It looks like ax plus by equals c. So this is standard form. All right, so what does the function for quadratic look like? What does a parent function look like? And what are the parts? Okay, so in quadratic, we're going to look at two parts of it. So once again, this can be found in your formula sheet. There are two parts. There's a standard form and there's a vertex form. So I'm just going to write those down and then talk about what each thing means. This is a listening check. Color in standard form. If A is positive, I just need you to remember it's a smiley face. If A is negative, it is a sad face. Okay. And then plus C right here, that's your y-intercept. Okay, what does the exponential one look like? So once again, you can find that in your formula sheet right there. There's only one of them. So that one is y equals a b x plus c. You seldom see the plus c out there, but in case you do, let's talk about what those things are once again. So your a is your initial, what you start off with, your principal, that kind of thing. Your b is your growth, if it's bigger than 1, or decay if it's less than 1. Okay, so depending on what that is, it's growth or decay. And then your plus C is your isotope. Okay, your isotope is that dotted line that it gets close to but never crosses. All right, so taking a look at the graph of all three. Okay, so taking a look at all three. A linear is simply a straight line, and it either goes up, which means it has a positive slope, okay, or it goes down, which means it has a negative slope. And you read that from left to right, okay. A quadratic is either a smiley face or a sad face. So smiley face, okay, if A is positive, or sad face if A is negative. Okay, an exponential, you have either growth from left to right, we're increasing, and it has like some isotope somewhere, and it gets really close to that, but doesn't quite touch it, and it increases really fast. Okay, so it might start off really slow and then goes up really quickly. Or you have a decreasing, so left to right, that's increasing. Left to right needs to be falling. So let me draw an isotope. And same thing, it falls really fast and then kind of levels out. Okay, so this one is growth. This one is decay. Okay, this one is a positive and this one is a negative. All right, identify it from a table. Okay, so how would I identify if it's linear, quadratic, or exponential? All I would need to do from a table is I would add or subtract to get the next y. Okay, so you have x, y, from here to here. Where did I add or subtract? That's linear. For quadratic, okay, it's the same thing, but instead of it doing it once, you're going to do it twice. So it's the same thing, same as linear, only twice. And that's called the second difference. And we'll work on some of those problems. What it means is you'll do it, add and subtract to the next number, then add and subtract the next number again. Okay, so I'll go over what that means. All right, and then exponential is multiplication. This is a listening check. Color in this entire box. All right, so you start off with 2, then it goes to 4, then it goes to 8, then it goes to 16. You'll multiply each time to get the next one. All right, average rate of change. Well, for average rate of change, if you look in the formula sheet, it says the change in y divided by the change in x for 2 distinct points in the graph. Okay, that's a rate of change. And remember, the change in y is simply y2 minus y1, and the change in x is x2 minus x1. The only difference as to why average rate of change is not called the slope is because for linear, it's a straight line, so it has a constant rate of change. All right, so really the average rate of change is y2 minus y1 over x2 minus x1 for all of them. But this one has a constant rate of change, which you know it as a slope. All right, for these two, they have an average rate of change, and that depends on interval. So with these two, okay, in fact, I'm just going to draw an arrow this way. With these two, it's the same thing. They depend on an interval, and what you see with that interval is you'll see x1, x2 in closed parentheses. So they're really asking you for the slope, which is the average rate of change. All right, domain and range. All right, domain and range for a linear. Listen, all I need you to do with domain and range for a linear is draw and arrows at the end. So remember, your domain is your x values, your range is your y values. Okay. For linear, from left to right, there will always be a graph, whether it's positive or negative. From left to right, there'll always be a graph. So your domain is going to be all real numbers. Same thing for every single one of these. From left to right, there's always going to be a graph. So really, your domain is always going to be all real numbers, whether you have a linear, a quadratic, or exponential. Okay, the only one you need to really be mindful of is word problems and sequences, and we'll talk about that later. All right, your range is your y values, okay? So from the bottom to the top, well, whether the slope is positive or negative, from the bottom to the top, this is also all of it, so all real numbers, okay? For this one, the bottom, the graph stops somewhere. So it stops here and then goes to or it starts here, from the bottom, starts here, goes to the top, right? So this point right here, what's that called? It's called the vertex, right? So for the range, if it's a smiley face, which means it's positive, A is positive. So I'll say A is positive, and I'll do A is negative. If A is positive, which means it's a happy face, so happy face, and this one's sad face. If A is positive, it's from the vertex to infinity, because that goes on forever that way, right? Including the vertex, so you can say closed vertex to infinity, and we are open on infinity because it's not a number. Or the other way you can say that is y is greater or equal to, right, because it includes the vertex. So two ways you can see it written, in interval term or as an inequality. All right, if A is negative, if it looks like this, right, the bottom of the graph is where? Negative infinity, and it goes up to the vertex. So it goes from negative infinity, don't include that because that's not a number, to the vertex, and you close the parenthesis because it includes the vertex. There is a point at the top of the graph. Or you can write that as y is less than or equal to the vertex, because once again, it's everything under here. All right, for growth and decay for exponential, you can see right here whether it's growth or decay, as long as it's not flipped, which means that A is positive. So if A is positive, then the range is from the bottom of the graph, which is the isotope, to the top of the graph, which is what? Infinity. Y is strictly greater, okay? Strictly greater because this never touches the isotope. You can see it never touches the isotope. So it's greater than the isotope. And remember, what's the isotope? See, A is negative because now if A is negative, I will flip it over the x-axis because it's outside, right? I'll flip it over the x-axis, it'll be below the isotope. That means the range will be, so it'll look like this, so it's below the isotope. Whether it was growth or decay doesn't matter. The range will be from the bottom of the graph, right? From the bottom of the graph, which is where? Negative infinity, all right, to the top of the graph, which is the isotope. So it'll be everything underneath the isotope. So everything under the isotope. Okay, not including it because it never touches. All right, end behavior. Remember, for end behavior, I just need you to show me the work for it. It's always asking, as x is going to infinity, what's happening to y? So as x goes to negative infinity, what's happening? Where is y going? That's what it's asking. Okay, so it depends on two things. If it's a positive slope, and remember, all I want you to do is draw arrows. So as x goes to the right, so the right of this positive, okay, where is y going to? So if this is the y-axis, where is y going to? It's going to positive infinity. So this is a positive slope. Okay, as x goes to the left, you just draw an arrow on the left. And if this is the y-axis, where is that going to in terms of y? It's going down this way forever, so that's going to negative infinity. Okay, if it is a negative slope, right here, so once again, you draw an arrow as x goes to the right, on the right, okay, right here on the right. All right, where is y going to? So if this is my y, where is y going to? It's going down to where? To negative infinity. Y is going to negative infinity. Okay, as it goes to the left, all right, so as it's going to the left, as x goes this way, y is going up forever. So that's positive infinity. Okay, so same thing with the quadratic. You just need to know if it's positive or negative. So as x goes to infinity, as x goes to negative infinity, what is y doing? So if it is a smiley face, y is going to, so if it's a smiley face, to the right, you draw an arrow to the right. Where is that going in terms of y? Up forever, so that's infinity. And to the left of the graph, draw an arrow. Where is that going? To positive infinity as well. Okay, if it is a sad face, meaning it's negative slope, y is going to, so as x goes to infinity, which is the right, so the right side of the graph, where is that going in terms of y? It's going down to where? Negative infinity. And if it is the left, so you draw an arrow on the left of the graph, where is that going in terms of y? To negative infinity. So just note for quadratic, as x goes to infinity, they're either both, if it's positive, they're both going to be, whether it's going to left or right, because they face the same direction, they're going to go to the same thing. If it's negative, whether you're going to the left or to the right in x, they're both going to head to the same place. So just keep in mind for quadratic, these two are always the same. Okay, so these you'll have different ones. These will always be the same. All right, finally, exponential. So as x goes to infinity, what's going on with y? And as y goes to infinity, what's going on with y? Again, if it is a growth, so it's going up like this, growth, and a is positive, okay, what's it doing? So if it's growth and a is positive, meaning you didn't flip it, what's it doing? So as x goes to the right, so you go to the right of the graph, where is it going? To positive infinity. So y is going to positive infinity. As it goes, I wrote that wrong. As x goes to the left, right, as x goes to the left, so you draw an arrow on the left, where is that going? Now, you see it's getting really close to whatever this is, but never touching it, so it's going to this line, and what do we call this line? The isotope. Okay, so y goes to the isotope. This is a listening check, underline isotope. I'll do it for decay and positive, so if I had a graph that looks like this, so it's decay, and a is positive, meaning I didn't flip it. As x goes to the right, it's going to the what? To the isotope. So y goes to the isotope. And as it goes to the left, as the furthest to the left of the graph, where is that going in terms of y? Forever up, so to infinity.